Hello friends, welcome to my YouTube channel. And as I have already made videos on classical mechanics, after classical mechanics, from today we are going to start a new course on quantum mechanics. And our today's topic that we are going to discuss first of all is wave function. Wave function. So what is wave function? So let's start. Now you see, in classical mechanics, suppose this is a particle of mass m, it is moving along x-axis and force applied on it is suppose F, which is also a function of x and t. And here you see, to find the position x at any time t, in classical mechanics we used Newton's second law, that is F is equal to ma. A means acceleration, that can be given by second order derivative of x, or this is negative of dl v by del x, where v represents potential. So now, but in quantum mechanics, if it is very small in microscopic, it is a microscopic particle, suppose if it is very small, then we need a wave function psi x, function of x and t. This is called wave function. I will explain it. What is it actually? Wave function. It can be obtained by Schrodinger equation, that is I h cut del psi by del t is equal to minus h cut square by twice m second order derivative of psi with respect to x, then potential v and psi. So this is the Schrodinger equation, and from this equation we can obtain what is psi. And here h cut is equal to h by 2 pi, its value is 1.054572 into 10 to the power minus 34 joule second. Okay, so now what does it do? What does the wave function do? To know it, we need statistical interpretation. So let me explain. Here you see, here this wave function, this mod of this wave function whole square gives the probability of finding the particle at a point x at time t. So this gives the probability. Okay, this gives the probability of finding the particle at a point x at time t. That means we can't say that the particle is at the point x. We can't be 100% sure at time t. Okay, just we can find a probability of getting there. Okay, so now more precisely we can write integration from a to b. So we need to find the probability of the particle within an interval, suppose between a and b, then mod of psi xt whole square dx. This gives the probability of finding the particle between a and b at time t, and this is given by the area below the curve, mod psi square versus x between a and b. Suppose if you draw a curve psi square versus x, then the area below this curve gives the area. Suppose we need to find the probability of the area below this curve gives the probability, sorry, not area. Suppose this point is A, this is B, and the probability of finding the particle between this interval is given by this area, this shaded region. Okay, so now let me explain with an example. Now, to understand the role of probability in quantum mechanics, let us take an example. A group of 14 people of different ages, here tabulated below the ages. So, age of 14 years, there is one people, and one people of 15 years, and three people of 16 years, two of 20 years, two of 24 years, and 5 people of 25 years. So now you see, if you see the table, from here we can find the probability of getting a particular age. Suppose how to find the probability of getting a particular age, suppose j. So how to get its probability? So we know the simple formula to find a probability. So number of times that this particular observation occurs, so n of j, and total number of observations, that is n. So here you see, if you add this number of people, that's going to be 14, as we have taken 14 people in the group, and sum of the ages here to 94. So let us forget about the sum now for the meantime. So suppose we need to find a probability of if you choose a man from this group, or choose if you select a person from this group, so what will be the probability that his age will be 14? So how to find it? So p of 14, that's going to be equal to how many people are there of 14 years? 1 people. So here it will be 1, and total number of total member 14, so it will be 1 by 14. Similarly, probability of 15 is 1 by 14, and probability of suppose getting a person of 16 years, so probability of 16 is 3 by 14, and this way we can find a probability of a particular age using this formula. Now here you see which is the most probable age. Here you can see, so most probable age is definitely 25. So 5 members are there of 25 years old, so probability of 25 is definitely 5 by 14, which is the greatest. This is the maximum probability, isn't it? So if you select a man or a member randomly from this group, then so chance of getting this 25 years old member is maximum. So similarly in case of quantum mechanics, suppose here you see, so if this is the curve of psi versus x, then if here is the in this region, if the maximum probability is maximum, then so the most probable region where you may get this particle is this region. So hope you have understood this. Now you see, let us observe one more thing. Now you can see how to find the average. We know the average. Here, before going to find the average, let me find a median. Okay, what will be the median? So let me write the ages in ascending order. 14, so 1 person, 15, 1 person, 16, 3 persons, so 16, then 22, 2 members 22 years old, and 24, 2 members, so 25, 5 members, 25, 25, 25, 25, and 25. Okay, so which one is the middle most? So 1 2 3 4 5 6 7 8 9 10 11 12 13 14. Okay, 14. So middlemost will be n by 2, that is here 14 by 2, that is 7, and n by 2 plus 1, that's going to be equal to 7 plus 1, that is 8. So 7th and 8th observation, 1 2 3 4 5 6 7. 7th observation is 24 and 8th observation is 24. 7th is 22 and 8th observation is 24. Now if you take the average of these two observations, so average of these two, 22 plus 24, that's going to be equal to 23. So here is the median age. Median age is 23 years old. And let us find the average. If you find the average of the ages, average ages will be sum of the total age, sum of the ages, that is here we are getting in this table 294, and divided by total member, that is 14 here, total member, that's going to be equal to 21. So 21 is the average. This is the average is. Now from here you can see, so this table, in this table neither 23 belong to this table nor 21 belongs to this table. Okay, though these two are average and median, but they are not in this table. That means probability of getting 23 and probability of getting 21 both equal to 0. Okay, so now you see, let me tell you that average in quantum mechanics. So in quantum mechanics, it is average is the quantity of interest, which is called expectation value. Okay, so we used to say expectation value here in case of quantum mechanics. So this average can be calculated in this way. Suppose we know probability of getting 14, we have got 1 by 4, and probability of 15 we have got 1 by, sorry, not for 14, here also 1 by 14, and probability of getting a member of 16 years is, suppose is in this case probability of 16 is 1 by not 1 by 13 by 14, 3 by 14. If you add all those, 3 by 14 means 3 into 1 by 14, because frequency of 16, that means number of times 16 occurs is 3, so that's why 3 into 1 by 14. So in general we can write, if you add all those probabilities, then you will get the average. So you can write summation j into p of j, probability of j, from j equal to 0 up to which it is going. So let me write here infinity, but here you see, that's how we can find the average. Okay, now you see this average in this in quantum mechanics, it is considered to be expectation value. Which means average is the quantity of interest. Okay, so now you see, so expectation value, it doesn't mean that it is certainly present there. Okay, so it is misleading. Why it is misleading? So now you see why it is misleading, expectation value. So here you can see, though which one is expectation value, we considered average as expectation value in quantum mechanics. Though here you see, in this case we have got average is 21 in this case, and if you see probability of 21 probability of 21 is 0. So expectation value is the value of interest in quantum mechanics that we want to obtain, but this value this term is misleading, as though we have got average is 21, but probability in this case, not in all cases it will be 0, but in this particular case here you can see there is no member of 21 years old in this particular example, so it is misleading. Okay, so now let us to better understand, let us take another two examples. Now if you say these two histograms, this one and this one, if you observe here, these two are histograms of different sets of data, but if you calculate here median, here we will get 5. If you calculate the median from this histogram, it is clearly 5, and here also you will get 5, and if you calculate the average, then also you will get 5. I haven't shown the calculation, I think you know that how to calculate average. Okay, here also you will get average. Average is 5, same average you will get. Though these two histograms are made on two different observations, two different sets of observations, but we are getting the same results in case of median and in case of average. So which thing will let us know that these two are histograms of different sets of observations? In that case, we must need a numerical measurement of amount of spread, so amount of deviation from the average value of other values. Okay, so how to find that? Now you see that deviation of a particular observation delta j is given by that value j minus the average value. That means in this case, now you see this is 4 is one observation, so we need to find the amount of spread from this average value. How to find that? That is 4 minus 5, isn't it? And for the observation 5 we will get 5 minus 5, and for this observation 6 we will get 6 minus 5. Now if you find the sum of these deviations, if you find the sum of this deviation, then what you will get? You have to add those, isn't it? Then you will get, here it is minus 1, this is plus this 0, this is again plus 1, then this become minus 1 plus 1 gone, this becomes 0, so this sum becomes 0. So that's why this 0 occurs because of this minus and plus sign, isn't it? In order to overcome this disadvantage, we need to find the variance. Okay, so where we will find the average of the we will find the average of the square of these deviations, average of the square of these deviations, then we will get a positive value, isn't it? So let me tell you how to find a variance, that is sigma square, that's given by the average of the squares of these deviations. Okay, and which is also equal to average of the squares of this observation and square of the average of these observations. These two difference of these two gives this variance. And if you find the standard deviation, standard deviation sigma, that's going to be square root of the average of the squares of the observation minus square of the average of this observation. Okay, so it is always a positive value. So since here you see this is always positive, that's why it must follow that this average of the squares of this observation must be greater than equal to square of the average. Okay, so observing the standard deviation, we can if you find standard deviation for different sets of data, you will come to know that these are the histograms of different sets of data. Okay, if you observe only the average and median, then you can't distinguish these two. Okay, so now in this case, that I have already told you that the probability of getting a particle between A and B. So why do we need this interval? So let us understand why do we need this interval. So why we choose a particular region to find the probability of getting the particle in that region. So now let me explain. Suppose now you see, suppose we need to select a random person of the street or of any place of suppose age 16 years old, not only 16 years 4 hours 27 minutes and 3.333 dot so on seconds. So probability of getting a person of this age is impossible. The probability of getting this age, this particular age is 0, because this age is frequently changing, isn't it? Because if you say 16 years 4 hours 27 minutes, that's okay. Within 1 minute you may find this, but it is impossible for us to find up to this 3.3 seconds, because it is changing. Okay, it is frequently changing because it is second is very small time for us. Okay, very small time for us. And in quantum mechanics we deal with the very small particles. That's why we need to choose a particular range. So instead of taking this particular age 16 years 4 hours 27 minutes 3.33 seconds, so we have to choose a range. So we have to select if you were asked to find the probability of getting a person, if you select randomly from of the street between the age 16 to 17 years, then you can find. Okay, within this range you can find, but you cannot choose people from the street of this particular age. Okay, so that's why here you see the probability of an individual. So we can write probability of an individual chosen at random lies between x and x plus dx. It is a small range. Suppose within this range is given by a quantity, that rho of x into dx. So here you see dx is the width of this interval, and rho x in this case it is known as probability density. This quantity is known as probability density. So it is not px, it is rho x. Okay, remember that px represents probability and rho x represents probability density. So probability between a and b, we can write integration a to b rho of x dx. We can write in this way. Now if you see, if you increase the range up to infinity, from minus infinity to plus infinity, then this probability must be equal to 1, because it is certain. Okay, if you are going to find something in a very large interval, that is certain to that is obvious that you're going to find that. Okay, suppose let me give you an example. Suppose this is the graph of the wave function versus x position. Okay, this is the wave function and this is the graph x comma t. Okay, so now you see, if you take only a small region, very small region, then the probability of getting the particle at this position is very less. If you increase the range from here to there, then probability increases. So if that means the area below this curve increases, means probability increases. So hope you have understood this. Now similarly, average of this x, this particular observation from minus infinity to plus infinity, it can be written as x into rho, not p, sorry, probability density x dx. And so similarly, the average of the function of x, we can write simply integration from minus infinity to plus infinity, replace this x by f of x into rho density dx. And similarly, we can find the standard deviation, variance, sigma square, that's gonna be average of the deviations, square of deviations, this, and which can be obtained by the average of squares of the observations minus square of the average of the observations. Okay, so now we are going to solve the, and in quantum mechanics, this probability density is represented by mod psi x of t whole square. This gives the probability density in quantum mechanics. So here a problem is, here we have to consider a Gaussian distribution. Rho of x is a into exponential minus lambda within bracket x minus a whole square, where a, small a, lambda are positive real constant. We need to determine a, that is capital A. We need to find the average of x, average of the squares of x, and sigma, and also we need to draw the graph of p of x. So here sigma means standard deviation. So first of all, what we're going to do here, so here rho of x is given, that is a e to the power minus lambda x minus a whole square, whole square. So we know that from minus infinity to plus infinity, integration from minus infinity to plus infinity, rho of x dx is 1. Okay, we have already discussed this, we have got this one. Now here you see, so here rho of x is this expression. Now put it here, and what you will get, it implies minus infinity to plus infinity, a e to the power minus lambda x minus a whole square dx, that's equal to 1 again. So a is constant, you can write this way, a minus infinity to plus infinity e to the power minus lambda x minus a whole square is equal to 1. Okay, so now here the limit, here the interval is minus infinity to plus infinity, so we can make it 0 to infinity. So to make it, we have to multiply here 2, then it will become 0 to infinity e to the power minus lambda x minus a whole square dx. So now let us assume, or let us put, x minus a is equal to u, which gives du is equal to dx. If you put it in this equation, this is suppose 1, then it becomes, equation number 1 becomes twice a 0 to infinity e to the power minus lambda u square du is equal to 1. Now Again, in this case, this function minus lambda u square, it can be written as, to I say, 0 to infinity e to the power, you can write this way, minus root over lambda u whole square. You can write this way. This part you can write this way, du is equal to 1. Now again, let us consider that root over root over lambda into u be suppose t. In that case, du will be dt by root lambda. So then this equation number, suppose this is 2, then this become equation number 2 implies a to I say 0 to infinity e to the power minus t square dt by root over lambda is equal to 1. Okay, now remember this result, that is 0 to infinity e to the power minus x square dx is equal to pi by 2. Okay, remember this result. If you don't know how, at the end of the video I will show you how we have got this. Okay, now here you see twice a, and you can write the lambda here, 0 to alpha e to the power minus t square dt, that is equal to 1. So I have already told you, apply this result, then you will get twice a by root over lambda, that will be equal to, okay. So hope you have got it. Now here 2 cancels, and here a will be equal to lambda by pi, root over lambda by pi. So this is the value of a. That's how we can. Now let me show you this integral as well, how to solve this. So here you see 0 to, if you take the left hand side, infinity minus e to the power x square dx. So if you consider that x square as t, then twice x dx will be dt, and here you see, in that case dx will be equal to dt by twice x. So if x square is equal to t, then x definitely it will be root over t. So we can replace the x by root over t. In this x is being replaced because here it is dt, so that's why we have to write this one in terms of t. So this becomes 0 to infinity e to the power minus t square dt by 2 root t. So 2 is constant, here we have to write half 0 to infinity e to the power minus, this should be only t, not square, this is t only, okay, minus t, then this dt by root over t, that can be written as t to the power minus half dt, or and t to the power minus half, it can be written as half minus 1. Now if you know the gamma function, so gamma n is equal to 0 to infinity e to the power minus x and x to the power n minus 1 dx. If you compare with this one, so instead of x there is only t, that is the difference, so expression is same, so we can compare this n with this half. Comparing n with half, comparing these two expressions, we get n equal to half. So if n equal to half, So here you see this term is going to be gamma half, isn't it? So we can write, so let me clear here. So we get half is equal to, we have got here gamma half, and value of gamma half, if you know how to evaluate gamma function, so then you will get pi. So our result is pi by 2. So that's why, and that's how we have got this result. Okay, so we have used this result here to find the value of this left hand side of equation number 2, and using that relation equation number 2 we have got the value of a. So we have got this answer of this first part. Now let us find average and sigma also. Now let us find b. Here we need to find expectation value, or you can say average. In terms of statistics it is average, and in quantum mechanics it is expectation value. So that gonna be we know this relation minus infinity to plus infinity, and x rho of x dx. Using this relation we can evaluate this. So minus infinity to plus infinity, here x, then rho of x is nothing but a e to the power minus gamma x minus a whole square dx. So that implies a outside here minus infinity to plus infinity, then x, and this is gamma, sorry, that should be gamma here, and x e to the power minus gamma x minus a whole square dx. So now here also we are going to substitute x minus a is equal to u. So then du is equal to dx, then we will get du equal to dx, and if you substitute this here, then you will get minus infinity to plus infinity, and then x will be u plus a. So here u plus a and e to the power minus lambda u square du. Okay, now how to integrate this? If you see, if you integrate this, so minus infinity to plus infinity, so here u e to the power minus lambda u square, then you will get plus a small a, then again here integration minus infinity, sorry, I should write here du to plus infinity, then here you must get e to the power minus gamma lambda a u square du. So now here you see that if you we have already evaluated this. Okay, so we have already evaluated this. Now let me evaluate this one. How to evaluate that? So here you see, now here you see, if you substitute lambda ut square lambda u square as t, then you will get du as this, and if you put here again applying substitution, what we have got here you can see this u will be cancelled out each other, and then this become integration minus infinity to plus infinity 1 by 2 outside, and e to the power minus t dt. And we know the integration of e to the power minus t is here minus e to the power again minus t. So we have got this. Here we have limit minus infinity to plus infinity. Then remember, t is nothing but minus half. T is nothing but minus u lambda square. So if you put here, if you replace this u by minus infinity or plus infinity, in both cases you will get plus infinity, because u square will be minus or plus. both infinity square will be plus infinity. And as here you can see this is minus sign, this is minus sign, so it will remain always as minus infinity, e to the power minus infinity, and e to the power minus infinity is 0. So that's why this term become 0. Hope you have understood this. Now you see we have already evaluated this part earlier, that is equal to a small a. What we have got, we have done when we have calculated this value of a. Okay, I have already shown you earlier. So that is equal to, this part is nothing but equal to pi by lambda. We have already evaluated this earlier. Okay, now value of a was lambda by pi, root over lambda by pi. Value of a, this one also we have evaluated. Now put here, if you put this value here, then you will get only a. So this is what we have got, average, or in case of quantum it becomes expectation value. So this is what. Now to find average of x square, what we need to do, so minus to plus infinity here, x square rho of x dx. So we need to find this, and rho of x is, we know, e to the power a into e to the power minus lambda x minus a whole square. So what we're gonna have here, minus to plus infinity. So let's keep the a outside as it is constant, x square e to the power minus lambda x minus a whole square dx. If you put x minus a is equal to u, then you will get u is equal to x plus, x is equal to or x plus a will be equal to x, and du dx will be equal. So if you put those, then this become a minus to plus infinity, then u plus a whole square e to the power minus lambda u square du. So if you expand this, then after simplification, then you will get a curl bracket minus alpha plus alpha, not alpha, infinity, then u square e to the power minus lambda u square du, then plus twice a minus to plus infinity u into e to the power minus lambda u square du, then plus a square minus to plus infinity e to the power minus lambda u square du. So now you see, if you remember, we have already calculated these two integrals earlier. Okay, we have already calculated those two. So what we can write, let me I will show you how to evaluate this. So let me keep space here, and we have already got this one is equal to 0. Okay, and a square, and we have already evaluated this earlier to solve a of this problem. So in that case we have got pi by lambda, root over pi by lambda, we have already got it. So now how to evaluate this part? So let me show you how to do that. So here you see, so u square minus to plus infinity u square e to the power minus lambda u square du. Now you see, if you consider only this part, let me show you, minus infinity to plus infinity integration e to the power minus this is equal to pi by lambda. We have already evaluated this earlier. So if you differentiate on both sides with respect to lambda, now if you differentiate with respect to lambda, then what will happen? So if you differentiate this term with respect to lambda, not u square, not u, if you differentiate it with with respect to lambda, then you will get minus 2 plus infinity minus lambda e to the power minus lambda u square, sorry, not lambda. If you differentiate it with respect to lambda, then you have to treat u square as constant. Okay, so du, then on the other side you will get, here pi is constant, lambda is variable, in that case you will get minus root over pi 2 lambda by lambda to the power 3 by 2. You will get this. So if you cancel these two, then you can see this part is equal to this result. So here we can put, instead of this we can put what? We can put this result here. What we have got? Root over pi by 2 pi 3 to the power 2 lambda, sorry, not pi, this should be lambda 3 to the power 2. We have got this. So hope you have understood this integration. So let me clean this part. Okay, now this is what we have got, average of x square. So here you see, now we are going to put the value of a here. If you put the value of a, that was root over lambda by pi, and if you simplify all those, root over pi by here root over pi by lambda, and here 1 by 2 lambda you can write like this, and here a square pi, sorry, root pi by lambda. So now if you multiply this, then you will get a square plus 1 by 2 lambda. So after simplification we will get this. Okay, if you simplify this you will get this. So this is our answer. And we also need to find the standard, we need to find variance. This is sigma square. So sigma square is given by, we have already got this, I have already explained, average of the squares and square of the average, their difference is this. So we have already got this, that a square plus 1 by 2 lambda, we have got this, we have put here we have put this value, then this one. So we have got that this average is equal to nothing but a. So here we will get a square only. So a square gone here on subtracting. So here it will be 1 by 2. Actually we are to find sigma, not sigma square. We have got sigma here 1 by 2 lambda. So sigma will be 1 by root over 2 lambda. So this is sigma. So we know that rho is nothing but a e to the power minus lambda x minus a whole square. We have got this, isn't it? So now you see, exponential, if you get exponential, if you put put any value of x, if you put any value of x, okay, this e to the power minus anything, it's never going to be 0. Now you see, e to the power minus, here if you have any value, then we will get very small value. Okay, if you get, suppose if you have e to the power minus 100, if you have e to the power minus 200, you will get very small values, but it is never going to be 0. Okay, and its value will be maximum when e to the power 0, that's going to be 1. So when it will be 1, when x will be equal to 1, okay, suppose this point is a, when x will be equal to 1, this will be maximum, otherwise it will vary like this. And so this is positive x-axis, this is row of x. Okay, this is the graph, required graph. So this is the required graph Hope you have understood. If you have understood, then please hit the thumbs up button and share with your friends. Share my videos, help me to grow my channel. If you are new to my channel, please subscribe.